Welcome to another lesson from Transparent Physics, and this one is on speed and velocity. If you watched the video on position, distance, and displacement, some of the themes that we're going to be talking about in this video will seem similar because we will be comparing measurements that are scalars to measurements that are vectors. The goals of this lesson include explaining the difference between speed and velocity, reviewing the differences between scalar and vector measurements in the meantime, and also we'll spend a short amount of time debating the scientific accuracy of titles of a very brief selection of 90s action movies. And we will quickly move into our first definition, which is the idea of speed. Speed is a scalar quantity, and a scalar quantity is a quantity that has only a magnitude, which means there is no direction necessary in order to understand the measurement in full. In this case, we're talking about the rate at which an object moves a certain distance, so that is solvable by taking the total distance traveled divided by the time that it took. We have a variable, lowercase v. Some people use an s instead. Yeah, it's whatever. But I'll use a lowercase v, and if you simply take the distance divided by the time, you can solve for the speed. This is sometimes referred to as an average speed because the distance traveled, technically you could be going fast, you could be going slow, you could change the speed, the rate at which you cover that distance. But as long as you have the total distance you traveled divided by the total time, you can get the speed. A variation of average speed is instantaneous speed, which means that we are not interested in the overall trend in the motion, but what are you doing at that exact instant? Again, this is one of those things that we sort of parse out for vocabulary things at the start of a course, but often doesn't come up that much later on. I don't know, in my opinion, at least for sort of introductory basic level physics classes. But your experiences may vary. The units are meters per second, and again, that goes straight to the idea of distance divided by time. And so we might have a speed of 14.2 meters per second. A similar theme when we talked about distance, position, and displacement. Speed itself sometimes is not enough information. As an example, you're driving your car in the Great Plains, radio broadcasts a warning that there's a tornado about 10 miles away from you are, and they said it's moving at 25 miles an hour. Does that mean you have to be worried? You don't have enough information. Just because you know how fast it's going, you don't know what direction it's going, and really you would need to know what direction it's going in order to know what your level of concern should be. So if we are going to include the idea of a direction, then we are going to need a vector quantity, and I did it again. I just noticed here on the slide before anything else comes up, we have a rogue arrowhead. The arrowhead indicates the presence of a variable that is a vector quantity in a certain formalistic notation. So there we go. I got 2 videos in a row. All right. So velocity is a vector quantity. It is a measure of the speed plus direction. So it's everything that's included with speed, and then we also tack on a direction as well, making it a vector quantity. A vector is a magnitude and a direction. When we solve for velocity, we are not using the distance traveled, we're taking the displacement. And again, there is a difference between the distance traveled and displacement. Distance traveled does not have a direction. Displacement traveled does include a direction. It could be as simple as a plus or a minus, or a certain angular or compass directions. When referring to velocity, again, officially, it should be a bolded variable or a variable with the vector hat on top of it. And when we're solving for velocity, it is the delta d, which is displacement, divided by the time. Again, I tend to streamline those after a little while because usually when it comes down to it, we're often talking about velocity most of the time anyway. So the assumptions are that the variable, even if we write it just as a simple v, refers to velocity as well. Still the same units, meters per second, and the example for velocity looks very similar to the example for speed. It's just we have an additional notation involving the direction, and the direction can be as simple as a plus or a minus. All right, now, and perhaps what's the most important part of this video, we are going to have to get real because we're going to talk about the movie Speed. And this is too important to do on a parched throat, so give me a moment while I take a sip of tea. All right, Speed, 1994 American action cinema classic featuring Keanu Reeves, Sandra Bullock, Jeff Daniels, and Dennis Hopper. Basic plot summary. There's a guy that knows a lot about bombs, puts a bomb on a bus. The bomb activates when the bus goes above 50 miles an hour. The bomb will explode if the bus drops below 50 miles an hour. The person driving the bus ends up being Sandra Bullock through a few twists of fate. Dennis Hopper is the guy controlling the bomb. He's trying to get back at Keanu Reeves, who is a cop, and his partner, Jeff Daniels. There's a lot going on. It's got a lot of great action adventure scenes. It is just, again, it's a very good movie, in my personal opinion. But Hollywood sometimes screws these things up. How is the name of the movie? Did they get that correctly in terms of the physics? So, Hollywood doesn't always get the science right. Is Speed a good name for this movie? I would say yes. Yes, it is, because this movie is really dealing with the idea of speed. The bus, technically the bomb on the bus, doesn't care what direction the bus is going. It only cares that the bus maintains a speed of 50 miles an hour. They can turn left, they can turn right, they can go whatever direction they want to, as long as they don't slow down below a certain speed. So I would say Hollywood got this one right. It was a scientifically accurate name, so you can enjoy it, not only because it is a solid action movie, but also the name works for the science as well. But filed under all good things must end, let's talk about Speed 2. Speed 2, the 1997 sequel to the runaway hit that was Speed 1, already wasn't off to a great start because Keanu Reeves didn't sign up for it again. Sandra Bullock was back. She's got a new boyfriend, Jason Patric, and they are celebrating their new relationship, and they're going on a cruise. Turns out the cruise that they go on is sort of like kidnapped by William Dafoe, and there's diamonds involved, but William Dafoe basically can control the boat. He can control the speed and direction of the boat. I don't know. I mean, honestly, cruise control, I never really picked up. A student of mine pointed out that the name cruise control is actually a pun on what the movie's about because he's in control of the cruise ship. So I thought that gave me a little bit more enjoyment out of it. And I do have to say, I didn't realize that Jason Patric actually was the lead character in another classic movie, The Lost Boys. So he was sort of the lead teenage character. So I do have a little bit more respect for Jason Patric. He had a haircut in this movie, so his hair was a lot longer before. So Lost Boys, also a pretty solid movie as well. So in any case, Cruise Control, not well received at all. It was a pretty bad movie, I would say. But it is what it is. As you can tell, I can only find 2 GIFs for Speed 2. There has to be more out there, but I couldn't find more really. So what are you gonna do? Let's say though, let's ask the same question: is Speed 2 named accurately? Should this movie still be called Speed? Honestly, it probably would have been better if it hadn't been Speed, but it's called Speed 2. Honestly, again, I do like to play on words, cruise control. But because William Dafoe controls both the speed and direction of the ship, they could have actually probably called it Speed 2 Velocity, and again, they would have lost the pun, but they would at least would have picked up a couple points for scientific accuracy. Okay, enough time for a speedy review of the topics we just discussed. Speed is a scalar quantity. It talks about how fast an object is moving. Think speed limit on a road. It tells you how fast you're allowed to be going. It doesn't really specify direction. Velocity, on the other hand, velocity is a vector quantity. It's everything you love about speed, plus the direction as well. In your car, a speedometer tells you how fast you are going. You don't have a velocityometer unless you also have something in your car that's telling you the direction you're traveling. If you do, then you know your speed and your direction, so you know the velocity as well. Speed the movie, classic of action cinema. Speed 2 the movie, cautionary tale for franchises gone bad. Okay, that'll wrap up this lesson. If you feel like it, go ahead and do the YouTube things. Go ahead, like, comment, subscribe. If not, go back and get your homework done. I understand either way. And as always, thanks for watching this lesson. Hopefully we've made things a little clearer for you with this lesson from Transparent Physics.